This is AP Calculus AB. We are on homework 4-8, spherical related rates. And number one, we have the spherical balloon. It's inflating at a rate of that 27 pi inches cubed per second. So if it's inches cubed, that's a key giveaway. That's going to be something with volume. And if it's inflating, usually anything that's inflating is also going to be volume. So those are the two key words here. And because we have a rate of change, this is going to be a V prime, which is going to be equal to that 27 pi. It's asking for the speed, how fast is the radius, so that's talking about an r prime. R prime is what we're looking for, and it's supposed to be increasing, so it should be positive when the radius is 3 inches, so the radius here is going to be 3 inches. All right, so we've written down everything that the problem gives us, and it tells us this formula for the volume of a sphere. If we're given V prime up here, we need to probably find V prime right here, so let's go ahead and find it. V prime, taking the derivative, this 3 is going to come down in front and cross cancel with this 3, giving us 4, and then pi r squared, because powerhouse 3 goes down into a 2, and then we multiply by the derivative of the inner. The derivative of r is r prime. So we have our equation. Let's fill in what we know. We first know that we have a 27 pi over here. We still have this 4 pi. Do we have an r? We do have an r. It's going to be 3, and that thing is going to be squared. And then we have an r prime. And if I'm taking a look at this equation, I have one equation with one unknown. We can just solve for that unknown. I'm going to go ahead and multiply all this stuff together first. So what do we have? This is going to be 27 pi over here on the left. And then, let's see, 3 squared is 9. 9 times 4 is 36. So I'm going to have 36 pi. R prime, and then finally I just need to divide both sides by 36 pi, so that's going to be R prime is going to be equal to 27 over 36. The pi and pi will cancel out. And I'm thinking for my static answer key, maybe I should show my work a little bit more thoroughly. In the past, I haven't done a very good job of doing that, so I'm going to say divide both sides by 36 pi, divide both sides by 36 pi. And again, these pi's and pi's will cancel each other out. I'm noticing that both the numerator and denominator are divisible by 9. So 27 divided by 9 is 3, and 36 divided by 9 is 4. So I get this r prime is equal to 3/4. And then we need some units. So it's going to be 3/4. And then what is happening here? It's a radius. So instead of being inches cubed, radius is just measured in inches. And am I talking about a rate? It's an r prime, so it's a rate. So it's inches per time. It's inches per second here. All right, moving on to number 2. We have a balloon being filled with helium, and it tells us it's 4 feet cubed. Feet cubed tells us that it's going to be volume. So we're going to say here that volume, and this is changing, right? It's a rate. So rate means it's volume prime, and it's going to be 4. And filled is our word that means positive. Do we look at the word up here that means inflating? Yeah, inflating is the positive word. If it was deflating, it would be negative. So filled is a positive word. What is the rate of which the surface area? Okay, so if it's surface area, it's talking about S prime, and that's what we're looking for. And it should be increasing, and it tells us that the volume is 32 pi. My handwriting here, I'm dragging my pen, so let me do a little bit better of a job. Volume is equal to 32 pi over 3, and it tells us 2 equations. Okay. So I'm noticing that I have a V prime here and an S prime here, which means we probably need to take the derivative of each of these. I can go faster with volume prime because we've already done that in problem number 1. This is going to be volume prime is going to be equal to 4 pi r squared r prime. I'm taking the derivative, and let's do surface area prime. So again, taking the derivative, this 2 is going to come down in front. 4 times 2 is 8. And then I have pi r, it went down to a power of 1, so this is r to the power of 1, and then now I need to multiply by the derivative at the inner, which is going to be r prime. So I have both these equations set up. Do we have any other information? Not really. I'm noticing that there are a lot of shared variables, r and r prime, so there's probably a fancy way to get from one to the other, but I'm going to go ahead and do kind of the brute force attack, which is what I want you guys to do as well. Just write down everything you know and see if you can solve for anything. So in this problem, we are trying to solve for S prime, which means we need an R and an R prime. And it feels like we don't have enough information. Let's just fill in what we know over here. On the left, I know that V prime is 4, so I'm going to say 4, and then rewrite the rest of this equation. We're going to say 4 is equal to 4 pi r squared r prime. And from here, I'm just going to try to get r squared r prime by itself. So let's go ahead and move the 4 pi over. So if I divide both sides here by 4 pi, 4 pi, 4 pi. What's that going to give me? It's going to be 1 over pi is going to be equal to r squared r prime. And I can't solve for either r squared or r prime because I need one more additional variable. Oh, okay. What have we not used so far? We haven't used the fact that volume is 32 pi over 3. Again, in AP Calculus, if it gives you a variable or it tells you some information, there are no red herrings. There are no misleading facts. You have to use it. So I'm going to plug that back into our normal volume equation, this one right here. So here I go. I'm seeing the v, and that v is going to be swapped out for a 32 pi over 3. So I'm going to come over here and say this is going to be, I usually do blue for substitution. So 32 pi over 3, and that's going to be equal to 4/3 pi r cubed. I'm going to multiply both sides by 3, and that gets rid of the 3. And I'm going to divide the right side by 4 pi, which means I divide the left side by 4 pi. And that's going to give me just an r to the power of 3. On the right, on the left, 32 divided by 4 is 8, and the pi's will cross cancel. What do we have here? Okay, I need to just cube root. So I cube root r is going to be equal to 2. 2 to the power of 3 is 8. 2 times 2 times 2 is 8. Okay, cool. Well, that helps us because this r is equal to 2 is probably going to come and be placed over in this r. So I can, I'm running out of room here, but I'm going to do my best to keep this organized. I'm going to move this surface area over there. Is that off the paper? No, okay. I'm going to put you right there. And then I'm going to come back over here and say, okay, let's continue this equation up here and say that this is now 1 over pi is equal to, we need an r squared. Hey, look, we have an r now. This is going to be 2, and then that's squared r prime. And again, if you're trying to follow me, 2 was plugged into this r squared, so that's why we have 2 here. And I can solve for r prime now. So I can say that's really 4 if I divide both sides by 4. So I say divide by 4, divide by 4. Then I'm going to get r prime by itself on the left-hand side, and 1 over 4 pi on the left-hand side. Again, I've shown this trick. Whenever you divide, you just kind of put it on the bottom. The rule for that is really quickly, and I'm going to erase this. I want to explain it once and be done with it for this assignment. If I have 1 over pi and I'm dividing that by 4, that's the same thing as a keep, change, flip. Keep it, change it, flip it. And you can see you're going to have a 4 pi on the bottom. All right, I'm going to go ahead and erase that, though. I'm just expecting you to know that for the rest of the video. Hey, so check it out. I have a surface area prime that uses both a r and an r prime. I have an r here and I have an r prime here. Let's plug both of those in. In fact, I can start moving these over a little bit, and I can actually see everything I'm doing all in one screen, I'm hoping. There we go. Okay, so I'm going to say now that surface area prime is going to be equal to 8 pi. Okay, here comes the substitution. So r is going to be 2. And r prime is going to be 1 over 4 pi. Okay, and then from here I just need to simplify all this stuff. So I'm checking it out. Pi and pi are going to cross cancel. And then I have 8 times 2 is 16. 16 divided by 4 is 4. So I'm going to get down here. Surface area prime is going to be equal to 4. And then I want this with units. So what I have here, it's going to be 4 something. What were my units? Okay, so I see feet cubed per minute. So this feet cubed is going to go to feet squared because it's surface area. So it's going to say feet squared. And then it's a prime. Prime means per time, and the time is already per minute. So I'll say feet squared per minute. There we go. All right. Moving on to number 3. The radius of a sphere is increasing at the uniform rate. Okay, so first of all, increasing is this word that means positive, so I'm going to make this a positive sign. And it's a rate, so it's an r prime. R prime here is going to be equal to 0.3. And at the instant when the surface area becomes 100 pi, so we know that surface area here is 100 pi. What is the rate of increase in cubic inches per second? Nice, it tells us the units in the volume. So we're just looking for a rate of the volume. So it's going to be v prime is what we're looking for. All right, well, if we need a v prime, we might as well find v prime again, and you're taking the derivative over and over again. Again, 3 comes down in front, etc., etc. V prime in this case is going to be 4 pi r squared r prime. And we also have surface area. Okay, well, I'm going to, notice in this problem there's no s prime. There's an s here, but there's no s prime. I don't think there's any need to take s prime unless it tells us to. So I'm just going to rewrite this equation for surface area, but I'll probably plug in the 100 pi for this surface area at the same time. So here it goes. I'm going to say 100 pi being plugged in is going to be equal to 4 pi r squared. And I can also plug in at the same time this r prime comes down over here to this r prime, and what is that going to give us? I have a v prime is equal to 4 pi, that's a terrible pi, 4 pi r squared, and then r prime is 0.3. All right, well, if I'm searching for v prime, notice that the only thing that I'm missing is an r squared. And check it out, I can solve for an r squared over here. And this is a cool little trick, guys. You don't have to solve for r. You can just solve for r squared, because r squared and r squared are the same number. I'm not going to solve for r. It's a cool little speedy shortcut, right? So over here, I'm going to divide by 4 pi, divide by 4 pi. Pi's and pi's will cross cancel, gone and gone. 100 divided by 4 is 25. 25 is equal to r squared. And you might say, okay, Mr. Sindel, yes, you're going to square root both sides and get r is equal to 5. Cool, yeah, you could do that, but you could do this. You could say, hey, this r squared is 25, which means this r squared is 25, and you could rewrite this equation like this. You could say that v prime is equal to 4 pi times 25 times this 0.3. Again, 0.3 probably should have been in blue. Oh, that was too big of an eraser. 0.3 should have been in blue because I was doing substitution there, wasn't I? I meant to do blue. 0.3. 0.3. I guess I should keep it blue. Come on, Mr. Sindel, get it together. This is 0.3. And what do I have from here? Well, I have, and I realized that there was actually a quicker way to do this. Here, I want to talk for a little bit in terms of speedy shortcuts. Check it out. Do you see a 4 pi r squared here? Do you see a 4 pi r squared here? I do. If 4 pi r squared is 100 pi, look at right here, 4 pi r squared is 100 pi, this 4 pi r squared is also 100 pi. I could have just skipped and said u turn into u, and that would have been faster, and then 100 pi times 0.3. Because I'm realizing now I'm like, 25 times 4 is 100 pi. Wait a sec, I've heard of 100 pi before. It's up there. Oh well. This is slightly long, but v prime is equal to 100 pi times 0.3. I'll make a note of it in this answer key. I'll say that this 100 pi right here is the surface area prime. And then I can come down here and just say the answer. V prime is, okay, so if I'm doing 100 times 0.3, that's going to be 30. So it's going to be 30 pi. And then I'm going to write out my answer over here. So it's going to be 30 pi. And then what is my unit? My unit over here becomes... Oh, it tells us cubic inches per second. So I'm just going to say cubic inches, which means inches to the power of 3 per second. Inches cubed per second. Excellent. All right, number 4. A spherical balloon is expanding at a rate of 60 pi inches cubed per second. Okay, so first of all, expanding is this word that is a positive. Deflating would be the negative word. And because it is inches cubed, we can clearly tell that this is volume. So this is volume prime is going to be equal to 60 pi, a positive 60 pi, might I add. How fast is the surface area of the balloon? Okay, so something about an expanding. So this is a changing word. So it's asking here for S prime is what we're after. And then tells us the radius is 4. So when R is equal to 4. Okay, so we have all the pieces. Hey, and this is one of those questions where we have both a v prime and an s prime, so let's go ahead and take the derivative of each of these equations, write them down. I'm sure they're going to be useful. So we have a v prime is going to be equal to a 4 pi r squared r prime, and surface area prime is going to be equal to an 8 pi r prime. And let's go ahead and move our radius is equal to 4 out of the way. Okay, and then from here we're going to plug in what we know. Okay, so v prime is 60 pi. V prime is 60 pi. Keep rewriting everything else down. This is going to be equal to 4 pi r squared. Oop, that was a terrible squared r prime. And we also know r. Oh wait, we know r is 4. So hold on, this r right here, we know who you are. Let's come back here and erase that. We're going to change that r into a 4. So we're going to say in here 4, and that's going to be squared r prime. And check it out, I'm just looking at this equation. We have everything except for r prime. We could probably solve for r prime if we needed to. And then over here for surface area prime, we don't have, oh, we have just this r. Oh, we're missing an r prime, and hey, I could find an r prime right here. So if I'm just going to fill in what we know, I know that surface area prime here is going to be 8 pi, and then we know that the radius here is 4. And this is going to be r prime. And we're going to plug into r prime. Let's see what we got here. This is going to be, we're going to solve over here. I have 4 squared, which is going to be 16, and then another 4 is going to make that 64. So over here on the right side, I have a 64 pi r prime, and then on the left-hand side, I have still my 60 pi. Let's go ahead and divide both sides by 64, let's say 64 pi. Divide both sides by 64 pi. And when I do that, the pi's and pi's will cancel out. This is going to be 60 over 64 pi. Let's see if we can reduce that. I think I can reduce that by dividing by 4, right? So if I divide the top and bottom by 4, I'm going to get, this looks like 15 on the top. Bad 15, let's rewrite that. 15 on the top, and 64 divided by 4 goes back to 16, and then pi's are gone. This is all going to be equal to just our r prime. And I can come back and plug this r prime into this r prime, right? So we can say now we have s prime is equal to 8 pi times still that 4, now times this fraction of 15/16. And then from here, let's go ahead and simplify as much as possible. Ooh, some cross canceling. So I have a 4 and a 16. The 16 will turn into a 4. And then, cross canceling again. Okay, so I have an 8 that will cross cancel with this 4. The 8 will turn into a 2 divided by 4. And now really what I have on the top is 2 pi times 15. 2 times 15 is 30. So this is going to be s prime is equal to 30 pi. And that was what we were after. So let's make sure that we have the correct units on this. So the answer is going to be 30 pi, and it's surface area, so it's going to be inches, not cube, but inches squared. And then it's s prime, so it's per time, inches squared per second. Moving on to number 5. If the radius of a sphere is increasing, again, increasing is this word that means a positive amount, and it's a rate, so it's an r prime here is equal to a positive 2. How fast in cubic inches per second is the volume increasing? It's asking for a v prime in this case. When the radius, when r is equal to 10. All right, well, we're asked to find a v prime. It's weird that in this problem they don't give you an equation. Usually they always give you an equation. So v prime in this case, I happen to know off the top of my head, is going to be 4 pi r squared r prime. And hey, I have an r and an r prime, so I can just plug those in, and I think I'm done. V prime is equal to 4 pi, okay, r is 10, so I'll say 10. That thing was going to be squared, and then I also multiply by r prime, which is 2, so times 2. And wow, that one was probably the easiest problem on this homework. So this is going to be v prime is equal to, let's think here, so 10 squared is 100, 2 and 4 is 8, 8 times 100 is 800, so this is going to be 800 pi. And we're done. So let's go ahead and answer this. This is going to be 800 pi. What are our units? Is volume prime. So it tells us, it actually tells us the units right here, cubic inches per second. So we'll do inches cubed per, that was bad, 3. Inches cubed per second. And box that. All right. Moving on to number 6. The radius of a sphere is decreasing. Okay, we finally have this negative word. So this is a negative word, decreasing at a rate. So it's an r prime is equal to a negative 2. At the instant when the radius of the sphere is 3, so it's telling us r is equal to 3. What is the rate of change? And it tells us the units square centimeters per second of the surface area. Ooh, there's a typo right there. I'm going to go ahead and fix that in the next video. Surface area, I'm going to give you a circle so I can find you later. Surface area of the sphere. So we're looking for s prime. Okay, if we need to find s prime, and again, there's another typo right there, that should be a capital S, then we need to take the derivative of this function. So we're going to say, okay, S prime, I know who you're equal to. You're equal to an 8 pi r prime. Again, this is one of those that I just plug it in. R prime gets plugged into R prime, R is plugged into R, and I think we're done with this one. Okay, so S prime is equal to 8 pi, R is going to be a 3, there it is, I was hunting for it, and then R prime is going to be equal to a negative 2, and we just multiply all those together. All right, so let's see, 8 times 3 is 24, times 2 is 48, so this is going to be negative 48 pi for number 6. All right, and we need our units, so this is going to be negative 48 pi, and then it tells us square centimeters per second, so centimeters squared per second, and we'll box that. All right, number 7, our final question for the homework. Volume of an expanding sphere. Okay, expanding is one of those words that means positive. It's increasing, so V prime is this positive 12. When the volume of the sphere, okay, so it tells us that the volume, not V prime, but just volume, is 36 pi. And we're looking for how fast in square feet per second is the surface area. We're looking for a surface area prime. This feels like a genuine AP question because we have a lot of different things happening at the same time. First of all, I have a V prime and an S prime and a V. There are 3 different equations that I'm going to be using here. So let's write down each of those equations. The first one is V. Oh, it already wrote that down for us. Okay, well, we might as well plug in. 36 pi is being plugged in for V. So down here, I'm going to say that this is going to be plugged in, so it's blue. It's going to be 36 pi is being plugged in. Let's rewrite the rest of the equation is equal to 4 pi r cubed all over 3. We don't ever use S, just S prime. So let's go ahead and write down S prime. S prime is going to be equal to 8 pi r prime. And finally, we need a V prime. So let's go ahead and take the derivative of our equation over here. And we're going to get, I need an equal to sign. V prime is going to be equal to 4 pi r squared r prime. And then from here, we just need to plug in everything that we know. So we've plugged in everything that we know to our first equation. There's no other r. Oh, we plugged in this value. We haven't plugged in this value. So V prime, this 12 can be plugged in over here. Let's see what we get. So I have now 12, and then rewrite the rest of the equation is equal to 4 pi r squared r prime. All right, there's a lot of things that I need to find. I mean, my scavenger hunt basically says, hey, I'm looking for S prime. That's what we're looking for. If I find an R and an R prime, I'm done. Well, I think we can find an R over here because that will be the unknown. And then once we find an R over here, we can probably plug that into this R to find for this, or solve for this R prime. Then we'll have both R and R prime. So I think that's the strategy. Let's go ahead and do this. So over here, on the left, I'm going to, I don't like fractions. I'm going to get rid of the 3 by multiplying by 3. So multiplying by 3, multiplying by 3 scares me a little bit because these are slightly large numbers, but we are going to cross cancel here. And we're going to have 4 pi r cubed on the right. On the left, 6 times 3 is the 18. I'm carrying the 1 in my head. And then 3 times 3 is 9, plus the 1 that I'm holding is going to be 10, so 108 pi. And then from here, I need to divide by 4 pi. So I'm going to say divide by 4 pi, divide by 4 pi, and that's going to leave me, okay, pi's will cross cancel, so that's going to be nice. So gone and gone are the pi's. 108 divided by 4 is really just half and half again. So 108, half of that is 54, half of that is 27. So this is going to be 27 is equal to r cubed. And then from here, I'm going to cube root, and this is going to be 3. So I'll say r is equal to 3. All right, so first part of the scavenger hunt done. Let's go ahead and plug in r over here. So this is going to be 3. And what we're missing, we have an 8 pi. We have an S prime. The only thing that we're missing is an R prime. All right, and now we come over here to the right. Let's plug in 3 for this r as well. So I'm going to say u r 3, and everything there is going to be squared. We have an r prime. We got a pi. We've got a 4, and we've got a 12. All right, continue on. What do we got here? This is going to be 3 squared, which is 9. 9 times 4 is 36. So I have a 36 pi r prime on the right. On the left, I have just a 12. Time to move everything on over. So what do we got? Divide by 36 pi. Divide by 36 pi, and then from there I'm just going to have 1 over 3 pi simplified. I want to keep that in a different color though. say 1 over 3 pi when I divide the numerator and denominator by 12. And that's going to be our r prime. And hey, look, scavenger hunt time. That was our r prime. So this r prime is this r prime. We're plugging this into u. All right, so I have a 1 over 3 pi over here being plugged in. And then from there, I'm going to cross cancel the 3 and the 3. And the pi's will cancel out as well. Oh my god, so many things are canceling. I think I just get 8 here. So let's go ahead and say our final answer here, s prime is just equal to 8. And then we need units on this. So for units, it says square feet per second. I just need to slap that on. I have 8 feet, oh, that's a terrible T, 8 feet squared per minute for my final answer, and I box that. All right. That concludes AP Calculus Worksheet 4-8 Spherical Related Rates. Thanks for watching.